Welcome to AI ConvoCast, where we bring you the latest in AI and tech innovation. Quick housekeeping. Check out the affiliate links in our description. Using them supports the show, and please don't forget to rate, review, and share if you like what you hear. Let's jump right in.
Today we will be covering DeepSeek V4 and its 1 million token context window, the developer reaction to GPT 5.5 pricing and coding performance, the security controversy around MCP toolchains, and Microsoft Research's AutoAdapt system for domain adaptation. DeepSeek has rolled out preview models for V4, with two main versions now available through its API V4 Pro and V4 Flash. The API supports both an OpenAI chat completions compatible interface and an Anthropic-style interface, so developers who already have apps wired up to common chat model formats should not need to rebuild everything from scratch. DeepSeek also says the older DeepSeek Chat and DeepSeek Reasoner model names are being retired on July 24, 2026. For now, those names map to V4 Flash, with non-thinking and thinking modes depending on which one you call. The biggest spec is the context window. Both V4 Pro and V4 Flash support 1 million tokens. In plain terms, that means the model can take in a huge amount of text at once, on the scale of long codebases, large document collections, extended chat histories, or multi-step agent work, where the model needs to keep track of a lot of prior actions. A bigger context window does not automatically mean better answers, but it does mean the system can work with much more information before it has to compress, retrieve, or forget anything. DeepSeek's official model card lists V4 Pro at 1.6 trillion total parameters, with 49 billion active at a time. V4 Flash is smaller, at 284 billion total parameters and 13 billion active. That active number matters because these are a mixture of expert-style models. Instead of using the full model for every single token, the system activates only part of the network for a given step. A simple way to think about it is a giant building full of specialists, where only the relevant teams are called into the room for each question. That helps keep computation lower than if every parameter had to fire every time. DeepSeek is also emphasizing efficiency in long context use, not just raw size. A Hugging Face technical write-up says that at 1 million tokens, V4 Pro uses 27% of DeepSeek V3, 2 single-token inference flops, and 10% of its KV cache memory. V4 Flash drops that even further, to 10% of the flops and 7% of the KV cache memory. Flops are a rough measure of how much math the model has to do. KV cache is the memory the system uses to remember the tokens it has already processed so it can keep generating without rereading everything from zero. For long-running agents, KV cache can become a major cost and hardware bottleneck, so those reductions are a central part of the release. The pitch is especially focused on coding, reasoning, and agentic tasks. Agentic tasks are jobs where a model does not just answer once, but keeps working through steps. Read files, plan edits, run tools, inspect results, correct mistakes, and continue. That is why long context and lower memory use matter. If an agent is navigating a repository, reading documentation, and holding a long task history, the model has to stay useful deep into the session, not just at the first prompt. Hugging Face's Ben Burtonshaw captured the release in one blunt line: the benchmark numbers are competitive, but not soda. It doesn't matter. The point is that DeepSeek is not only trying to win a leaderboard screenshot. The more practical claim is that V4 can make long context agents cheaper and easier to run, especially in settings where keeping a million token working memory would normally be too expensive or too slow. The open checkpoint angle is also important for developers and researchers. With open model weights, teams can inspect, run, fine-tune, and deploy the models in ways that are not possible with a closed API-only model. That does not make deployment simple, especially at this scale, but it changes who can experiment with frontier-style, long-context systems. V4 Pro is still a very large model, while V4 Flash is positioned as the more lightweight option for teams that want lower latency or lower cost. The release puts a lot of attention on a practical question, not just how smart is the model, but can it keep working when the task is long, messy, and tool-heavy? OpenAI's GPT 5.5 launch is now moving from first impressions into developer economics. The model arrived for ChatGPT and Codex workflows, and OpenAI is positioning it around agentic coding, computer use, office work, and scientific research. In other words, the company is selling it less as a nicer chatbot, and more as a system that can finish complicated tasks with less human back and forth. The benchmark numbers are strong, especially on coding and terminal-style tasks. OpenAI says GPT 5.5 reaches 82.7% on Terminal Bench 2.0 and 58.6% on SWE Bench Pro. Terminal Bench tests whether a model can operate in a command-line environment where it has to understand instructions, run commands, read outputs, and continue toward a goal. SWE Bench Pro is focused on real software engineering problems, usually requiring the model to understand a codebase and make changes that pass tests. Those are harder than simple coding prompts because the model has to deal with context, debugging, and multi-step execution. OpenAI also says GPT 5.5 improves over GPT 5.4 while using fewer tokens across its coding evaluations. That detail matters because token count is part of cost and speed. If a model is more expensive per token but needs fewer turns, fewer retries, and fewer total tokens to complete a job, the real-world cost can be less obvious than the sticker price. The company is clearly trying to make the case that the model's better completion rate and token efficiency can offset higher rates, especially for developers using codecs on substantial coding tasks. But the sticker price is what developers are reacting to first. GPT 5.5 is listed at $5 per 1 million input tokens, 50 cents per 1 million cached input tokens, and $30 per 1 million output tokens. That is exactly double GPT 5.4 feet's standard rates of $2.50 for input and $15 for output. Cached input is cheaper because it reuses context the system has already processed, which can help when an app repeatedly sends the same files, instructions, or project context. Still, for users doing lots of code generation, output tokens can add up quickly. The codex credit pricing mirrors that jump. GPT 5.5 uses 125 credits per 1 million input tokens and 750 credits per 1 million output tokens. GPT 5.4 uses 62.5 and 375. So the developer debate is not only whether GPT 5.5 is better. It is whether it is enough better to justify doubling the rate, especially for people who run large coding sessions, let agents iterate, or hit weekly usage limits quickly. The reactions are split in a way that is pretty revealing. On r/codex, one user wrote that they ended up using all of weekly limits in 6 hours, while also calling GPT 5.5 so good. That is the tension in one sentence. Strong performance can drive more usage, and more usage can make limits feel tighter. On r/OpenAI, another commenter, Astronomat, cut straight to the price. Lol, it's twice as expensive as GPT 5.4. That reaction matters, because developers are not just comparing demo quality. They are calculating whether the model can replace enough manual work, or enough failed attempts from cheaper models to make the economics work. There is also a hardware detail behind the release. OpenAI says GPT 5.5 was co-designed, trained, and served on NVIDIA GB200 and GB300 NVL72 systems. That is not just a branding note. These systems are built for extremely large-scale model training and inference, with high bandwidth connections between chips so the model can move data quickly. For users, the relevant part is that serving frontier models is not just about the model file. It depends on specialized infrastructure, and that infrastructure cost eventually shows up in pricing, rate limits, and availability. So the GPT 5.5 follow-up is less about whether the model is capable. The early data says it is very capable on agentic coding benchmarks. The sharper question is when to use it. For high-value coding tasks where one successful completion saves hours, the doubled price may be acceptable. For bulk generation, experiments, or always-on agent loops, developers are already watching token use carefully. The model's advantage may depend on whether it can finish jobs in fewer tries, not just whether it produces better code when money is no object. The third story is a security controversy around MCP, the Model Context Protocol. Security researchers at OX Security disclosed a systemic weakness in the MCP ecosystem, with coverage from the Hacker News and Tom's Hardware this week. The issue centers on MCP's STDIO transport and the way user-controlled configuration can flow into local process execution. In simpler terms, MCP can let an AI tool talk to local programs, and the concern is that certain configurations can cause the system to run commands on a machine in ways that are dangerous if an attacker can influence them. MCP has become a common way for agents and apps to connect to tools. A model on its own can generate text, but an agent usually needs access to things like files, databases, browsers, terminals, calendars, or internal business systems. MCP is meant to standardize that connection layer, so developers do not have to build one custom integration for every model and every tool. That is useful, but it also means security problems in the protocol or its defaults can spread across many products. According to the Hacker News, OX described the issue as a, quote, by design architecture weakness that can enable remote code execution. Remote code execution, often shortened to RCE, means an attacker can get a system to run commands or code they choose. That is one of the most serious categories of vulnerability because it can lead to data theft, malware installation, credential access, or deeper movement inside a network. OX researchers put it directly. This flaw enables arbitrary command execution, RCE. The reported scale is large. The Hacker News said the weakness affects more than 7,000 publicly accessible servers and software packages, totaling more than 150 million downloads. Tom's Hardware reported the exposure could ripple across up to 200,000 server instances. The affected or exposed ecosystems named in the reporting include LiteLLM, LangChain, LangFlow, Flowise, LedaAI, LangBot, Windsurf, GPT Researcher, and DOCS GPT. That list matters because it spans frameworks, developer tools, agent builders, and applications that people use to connect models with real systems. The controversy is not just that a bug exists, it is that the behavior was reportedly treated as expected. Tom's Hardware says Anthropic told researchers the behavior was expected, which shifts the debate from patching one bad line of code to whether the protocol's design makes unsafe outcomes too easy. In security, working as designed can be more uncomfortable than a normal bug, because it means many implementations may have followed the pattern correctly and still created risk. A simple example helps explain the concern. If a local MCP server is launched through a configuration file and parts of that configuration can be influenced by something untrusted, an attacker may be able to insert commands where the system expects a safe argument. The AI model does not necessarily need to be malicious for this to go wrong. The dangerous path can come from the toolchain around it: configs, shell commands, package scripts, environment variables, and local permissions. Once agents are allowed to act through tools, the boundary between the model suggested something and the machine executed something becomes extremely important. MCP's footprint makes the issue more consequential. Anthropic donated MCP to the Linux Foundation's Agentic AI Foundation in December 2025 and said it had been adopted by ChatGPT, Cursor, Gemini, Microsoft Copilot, VS Code, and others. Anthropic also cited more than 97 million monthly SDK downloads across Python and TypeScript. That does not mean every download is vulnerable in the same way, but it shows why researchers are treating MCP as infrastructure rather than a side project. For developers, the practical takeaway is to treat MCP servers like software that can execute with real permissions, not like harmless plugins. That means reviewing configurations, avoiding untrusted inputs and launch commands, sandboxing where possible, limiting file system and network access, and watching which MCP servers are installed automatically by tools. The useful part of MCP is that it makes agents more capable. The risk is that capability often comes from giving software permission to touch more of the machine. Microsoft Research has introduced AutoAdapt, a framework for automating domain adaptation for large language models. The work was published on April 22, building on an ARC's white paper submitted in March. The goal is to help teams adapt general-purpose models to specialized domains like law, medicine, finance, customer support, or cloud incident response, without manually guessing which customization method to use. Domain adaptation is the process of making a general model perform better in a specific setting. A general model may know a lot, but a hospital, bank, legal team, or engineering organization often has its own terminology, documents, workflows, policies, and accuracy requirements. There are several ways to adapt a model. RAG, or Retrieval Augmented Generation, lets the model search external documents and use the retrieved material in its answer. Fine-tuning updates the model using examples. LoRA is a lighter-weight fine-tuning method that changes a smaller set of add-on parameters instead of retraining the whole model. Alignment steps can tune behavior so outputs better match a company's rules or preferences. The hard part is choosing among those methods under real constraints. RAG may be cheaper and easier to update when documents change, but it depends on retrieval quality. Fine-tuning may improve style or task performance, but it can cost more and may be harder to refresh. LoRA can be more efficient than full fine-tuning, but it still requires the right data and evaluation. Some teams also have privacy rules that prevent data from leaving a secure environment. Others have strict latency budgets, meaning the system has to answer quickly, not just accurately. AutoAdapt takes into task objective, available data, and constraints such as accuracy, latency, hardware, privacy, and budget. It then plans an executable adaptation pipeline. Microsoft describes this through an adaptation configuration graph, which represents possible adaptation choices, and a budget-aware optimization loop called auto-refine. Put simply, AutoAdapt tries different paths in a structured way, checks how well they work, and refines the plan while staying within the limits the team set. Microsoft's framing of the problem is practical. The company says teams don't just need a better prompt or more data. They need a decision process that maps their domain data and constraints to an adaptation strategy that works. That quote matters because it pushes against a common shortcut. When a model underperforms in a specialized setting, the answer is not always write a longer prompt or throw more documents into retrieval. Sometimes the right fix is a different architecture, a smaller tuned model, a better retriever, an alignment step, or some combination. The paper reports that AutoAdapt achieved a 25% average relative accuracy improvement over state-of-the-art AutoML baselines across 10 tasks, with minimal overhead. AutoML means automated machine learning, systems that try to automate parts of model selection, tuning, and pipeline design. In this case, the benchmark is not about making a new foundation model. It is about making the adaptation process itself more repeatable, measurable, and less dependent on trial and error. For enterprise teams, one of the useful pieces is the explicit handling of trade-offs. A legal research tool might prioritize citation accuracy and privacy. A customer service assistant might prioritize latency and cost. A cloud incident response assistant might need speed, up-to-date internal documentation, and reliable action recommendations. AutoAdapt is meant to reason over those constraints instead of optimizing for one generic score. The system also reflects the reality many teams run into after early pilots. The model is only one part of the final application. The data pipeline, retrieval setup, fine-tuning strategy, evaluation harness, hardware target, and governance requirements all affect whether the application works. AutoAdapt's value is in turning those decisions into a more systematic workflow, so teams can compare adaptation strategies with clearer evidence, rather than relying on whichever method was easiest to try first.
Thank you for listening to AI Convo Cast. Please don't forget to rate, review, and share if you like what you hear. Thanks and hope to see you again next time.